In this video, we are going to focus on parabolas. Parabolas is something that we've seen before, but we've only seen the ones that open up or open down, and we've done very little with them. We've talked about minimums and maximums, but we haven't talked about things like the directrix and the focus, and that's what we're going to see today. So what is a parabola? Parabola is a collection of all points in the plane that are the same distance from a fixed point as they are from a fixed line. Now that line we're going to call the directrix, and that fixed point we're talking about is going to be called the focus. So the distance between the focus and any point on that graph is going to be the same as the distance between that same point, P, and the directrix, that line. So let's look at formats for parabolas. When we talk about parabolas, we can open one of four ways. We can open left, right, up, and down. So if we have something that we can write this way, then this is going to be something that's going to open to the right. So if it opens to the right, it's going to look something like this. The focus is a point that lives right above the vertex. So it's going to be a set distance away. It's actually going to be a points away from that vertex here. And then the directrix is going to be the other way. It's going to be a line that's never going to cross that quadratic, but it's going to be the same distance from this vertex to the directrix as it is from this vertex to inside to that focus point. So that's why when we look at this equation, HK is the focus, and then we're going to move A inside to find the, HK is the vertex. We're going to move A inside to find the focus, and we're going to move A outside to find the directrix. Okay, if we have a negative in front of this, okay, but notice the y is still squared just like it was in the other one, it's going to open the other way. Okay, so now my focus is going to be in here and my directrix will be out here. So vertex, this time we're going to move to the left to find the focus. That's why we're subtracting A. And to find the directrix, we're going to move to the right. Okay, now in both of these cases, that directrix was going to be a vertical line. That's why it's the equation x equals something. These are the two that we're more familiar with. If we're squaring x, then we have something that's either going to open up or down. So in this case, our A is going to be positive, so this guy's going to open up. So it's going to look like this. So there's my vertex. Inside is going to be the focus. So notice in this case, I'm moving up to find the focus, right? A units. And the directrix is going to be a horizontal line, and I'm moving down to find that. So if you draw these pictures as you go, it's going to make it really easy to say, oh, this has to be the focus, this has to be the directrix. And then if A is negative, we know it's going to open down. So once again, focus lives inside. So now I'm moving down to find the focus, and the directrix, I'm moving up. So let's look at a few examples. It's going to help if we take these and we write them in standard form. So let's start with number 44. So we've got y plus 1, which is the same thing as y minus negative 1 squared, equals, and there's a negative 4, so that means A's got to be 1, because that's how I would get a negative 4 there, times x minus 2. So if we compare this with our formats, okay, notice it's fitting this format. Okay, so we know where the vertex is. It's going to be at HK. We also know it's going to open left. So my vertex is at HK. So I'm going to draw a quick picture so I can see what's going on. So HK, here's my vertex, opens left. It's going to look like this. Now we need to identify A, and our A is going to be a 1 here. So that's why that format's important, because it's really easy to identify what A is going to be. So the focus is going to live inside, and we're going to move A units here. So our focus is going to move to the left 1, which means we're going to be at 1, -1. So to find that focus, all we're going to do is we're going to move to the left 1. So we're going to subtract 1. And that's what our little cheat sheet says, right? We're going to take H and subtract A from it. And the K value is going to stay the same. Now to find the directrix, remember this is going to be a vertical line, right? Because it opens to the left, and the directrix cannot cross the vertex or the parabola anywhere. So we're going to move to the right 1. So if we go back to our little picture here, I'm going to move A units this way, which is 1. So if I move 1 unit and I draw that line, that's going to be the line x = 3. We can also talk about something called the axis of symmetry. And that's something you probably saw in a pre-cal class somewhere. Axis of symmetry is the line that cuts this guy in half. So if I were to cut this guy in half, I would have to do it this way. And in this case, the top and the bottom halves are going to match. So that's going to be the line y = -1. That's going to be a horizontal line, and it's got to go through that focus there. So let's take all of this and let's put it in Desmos. So I'm going to start by graphing the equations. So we've got y - -1 or y + 1 squared equals -4 or -4 times 1 times x - 2. Okay, so there's my graph. We said that the vertex was at 2, -1, so you can see that vertex happening. We said that the focus was at 1, -1. So I'm going to zoom in. I'm zoomed out pretty far here. So there it is. And we said that the directrix was the line x = 3. So there's my directrix line. And the axis of symmetry was y = -1. So there's all my pieces to that. And usually when we draw those kind of graphs, we want them to be dotted lines. So if we were doing this on paper, we would draw this as a dotted line, and we would draw that directrix as a dotted line. Okay, let's do one more. Let's look at number 48. So 48, we're going to have to complete the square before we start. So we're going to group the x terms together. So I've got x² + 6x. And I'm going to move the y and the 1 over. So when I complete the square, I take half the middle and square it. Half of 6 is 3. 3 squared is 9. If I add 9 here, I'm going to add 9 over here. So this factors into x + 3 times x + 3, which is x + 3 squared. And then we're going to have 4y + 8 here. So now I'm going to have to factor this. So 4, and this is going to be y + 2. So now I'm in standard form. I'm going to do a little tweaking here. So this is going to be x - -3. And this is, we're going to view as 4 times 1 times y - -2. So if we were to compare up here, so we had a positive in front and we had our x term squared. So we're going to follow this third line. We know this guy's going to open up. We actually knew that from pre-cal algebra, right? So let's figure out everything we need to do. So vertex. Vertex is at HK, -3, -2. Our A value is 1, and it opens up. So if you can draw a picture of what's going on and you can identify the vertex in A, you don't need to memorize the formulas for the directrix and the focus. We can use some logic to help us figure that out. So here's our picture. Okay, this is at -3, -2. So if I want to find the focus lives inside of the quadratic, and we're moving up 1 unit. So if I move up 1 unit, I'm going to be at this point. So that's going to be at -3, -1. All we did was add 1 to that y value. The directrix is going to go the other way. Okay, so we're going to go down 1. So here's my directrix line. And if I go down 1, notice it's horizontal, down 1 from the vertex would put me at y equals -3. And then the axis of symmetry cuts this graph in half. And that's going to be at x equals -3. So if we wanted to graph everything, this was our original equation. So when we completed the square, we got this. So you can see those are the same equation, just a different way to write it. We found the vertex, which is down here. We found the focus, which lives up here, and we found the directrix, which lives down here. And then the axis of symmetry cuts that graph in half. So let's do one more, and let's look at 43. And you may want to pause the video, try it, and then come back. So in 43, we've got this. Now we know by comparing with the formats, the sky is going to open down. So we have x minus 3 squared equals negative times y minus -1. But we've got to figure out what's going on here. So we've got a -1, and that's got to be equal to -4a. So how can we rewrite that? If we were to solve this for a, we can divide both sides by -4, and we're going to get 1/4 for a. So we could rewrite this as -4 times 1/4. And the reason we would want to do that is because we need that a value. So vertex is at 3, -1, and we know it's going to open down. So let's draw a picture of what's going on. So we're over here at 3, -1. And it opens down, so it's going to look like this. The focus has to live inside here. So we're going to move down 1/4, 1/4, 1/4 of a unit. So we're going to take -1 minus 1/4 to move down. So that's going to be at 3, -5/4. Now the directrix is going to be the other way, because the directrix, we've got to move up 1/4 unit. So it's going to be this one. It's not a vertical line, it's a horizontal line. So it's going to be -1, right? And then we're going to move up 1/4. So we've got -4/4 plus 1/4, which would be -3/4. And then the axis of symmetry, I'll abbreviate that, cuts this graph in half. So it's going to be a vertical line going through the vertex. So if we were to graph everything in Desmos, here's our quadratic. We found the vertex here. We moved inside to find the focus. We moved outside to find the directrix. And the axis of symmetry cuts the graph in half.